Hey, everybody. Thanks again for joining me for the next lesson. We've got populations and samples, and we're going to start off with a little bit of vocab today. What we want to be able to do is to compare and analyze sampling methods. Basically, we want to be able to see is the sample that somebody took, the data that they gathered, is that credible or not? All right. First vocab word is population, and that's the entire group of objects or individuals considered for a survey. Okay, so like maybe I'm asking the entire seventh grade class what their favorite candy is. Okay, the population would be the entire seventh grade. The sample is a part of the population, so a part of the population. So that would be like if I said, okay, I'm just going to ask the people with blonde hair in the seventh grade what their favorite candy is. All right. That's just people who have blonde hair in that population of seventh graders. A random sample is a good thing when collecting data, and that's a sample in which each individual or object in the entire population has an equal chance of being selected. Has an equal chance of being selected. So that's really making sure that, say we took a school-wide survey, we wouldn't just want to ask the seniors, or we wouldn't just want to ask the sixth graders. We'd want to make sure we're taking random students from every grade to make sure that it's an equal chance of being selected for everyone. A convenience sample isn't really a good measure of data because it's a sample in which each individual or object in the entire population. Okay, so it's going to start off the same way. A sample in which each individual or object in the entire population is picked based on being readily available. So that would be like me asking you guys a question for the entire seventh grade. Like, say for instance, I'm teaching this right now and it's third hour, so I'm just going to ask the third hour seventh graders. I'm not going to worry about the seventh hour seventh graders. Well, why did I do that? Well, it's just convenient. It was just readily available. It's third hour now, and you guys are in my class, so I'll just pick you now. Well, how do you think the seventh hour seventh graders are going to feel about that? They're going to want to say as well. So that's usually not a good sample on data because not everyone has an equal chance of being selected, like in the random sample. And lastly, a biased sample is a sample that does not fairly represent the population. So that would be like if we were voting on which movie to go to, and I only asked the guys in class, hey guys, which movie do you want to go to in class? And none of the girls got to vote. Well, the girls are going to feel left out, and that doesn't represent our entire population of our class. We have guys and girls in here, so um, that would be a biased example. It's kind of one-sided, in other words. All right, let's after getting some vocab in, let's take a look at a few of these examples and see what types of problems we'll be dealing with today. It says determine which sampling method will better represent the entire population and justify your answer. So what we're talking about is band uniform style. And there's two different sampling methods here. In the first one, Maria surveys only the band students she knows personally. And the results were that 84% want blue uniforms. John, however, writes each band student's name on a card, and he questions those students whose names he draws. And of that, 61% of those random people want blue uniforms. So, whose method produces a better result that represents the entire band population? Well, that would be John's method. John's method produces the better results because he uses a random sample. That's the key. Maria is surveying only people she knows personally, and it's not really fair that because she's probably gonna survey the people like her, and that's gonna give her skewed results. Maria's method produces results that are not as representative of the entire band population because she uses a convenience sample. She just says, "Oh, I know these people. I'll just ask them what they like." Well, that's not a random sample. You can get better data by being totally random. Okay, let's flip to the next example. It says the mayor surveys 100 supporters at a rally about the most important issues to be addressed by the city council. Okay, we're trying to determine whether this sample may be biased and then explain. Okay, the mayor surveys 100 supporters at a rally about the most important issues to be addressed by the city council. Well, is this biased or is it not biased? Well, it is biased. It is likely that the supporters may have different ideas than those not at the rally. That's like maybe you've seen something on the news before about people protesting something. Well, if you just survey the people that are protesting, what about all the other people who may like that law or like that rule or like whatever they're protesting? You can't just survey the people that are there because they probably feel important about it. So that's definitely a biased sample. Letter B says the principal sends out questionnaires to all of the students to find out what kind of music students prefer at dances. So the sample is not biased because it is random, because he sends it out to all of the students, because every student has a chance to respond. So that's not biased. That's a good thing when a sample is not biased. All right, let's look at our last example. Here we're going to use some proportions to see if we can find the actual number. So it says a principal of a school of 1,500 estimates that about 400 students will attend a band festival on Saturday. A random sample of 25 students showed that 6 of them will attend. Determine whether the principal's estimate is likely to be accurate. So he said rather than survey 1,500 students, which would take probably a good amount of time, he just picked 25 random students and found out that 6 of them will attend. So he's thinking Of those 25, can I use my 6 out of 25 to estimate for my total student body? So we're going to use a proportion to predict the total number of students that will attend. So how can we do that? Well, we can look at the sample size. So the students attending in the sample were 6 of them over the total. So how many students did he sample? He sampled 25. Should be equal to the students actually attending in the population over the size of the actual student body. So we don't know how many students will be attending that are in the population of this 1,500. That's what we're trying to estimate. And what is the size of our population of our student body? That's 1,500. Okay. So let X represent the number of students that will attend the band festival. That's what we're trying to estimate or guess, if you will. So we're just going to use a little bit of cross multiplication here. 6 times 1,500 equals 25 times X. When we take 6 times 1,500, we'll come up with 9,000 equals 25X. And then lastly, to X is being multiplied by 25 on each side. To undo that, we would divide by 25 on each side. 9,000 divided by 25 would give us 360. So, based on the sample, we found 6 out of 25 students would attend. You can predict that 360 students will attend the band festival. The principal's estimate, he estimated it to about 400, is likely to be accurate. He took a random sample of just 25 and used that to cross multiply to find the actual number of students from his estimate that he thinks will be there. So 360 is pretty close to that 400 that he was estimating at first. All right. We've got 3 check it out problems here. Please pause the video now and try these on your own. It says determine which sampling method will better represent the entire population. So we've got Pedro surveys the offense on his football team, who was the team's most valuable player. And 87% said it was the quarterback. Chad surveys 5 players from the offense and 5 from the defense on his football team on who was the MVP. And 65% said the quarterback was. Whose method is a better representation of the entire population? Well, that would be Chad's. And the reason is because Chad's method produces results that better represent the entire football team because he uses a random sample. He uses a random sample, and Pedro just surveyed the offense, where Chad surveyed 5 from the offense and 5 from the defense. Okay, so Chad had some included and used, I'm just going to put offense and defense. Okay, he used a little bit, he got the opinions of more people. If you're asking just the offense, chances are the offense are going to pick players who play on offense. So that's why it's pretty clear that more people set the quarterback when he just surveyed the offense. But when you add some input from defensive players, that number decreased, which is pretty normal. So Chad's is more random. Number 2 says determine whether the sample may be biased and explain. The owner of a record shop surveys only customers over the age of 18 who shop at his store. Well, this is not random. Because customers under 18 uh, don't have a chance of being chosen. Don't have a chance at being chosen for that survey. Okay. And chances are there's people who are under 18 who might go to that shop. So um, that is definitely not random and it does show some bias. Lastly, number 3 says the owner of a large chain restaurant with 1,200 employees estimates that about 250 employees will ask off for winter vacation. A random sample of 40 showed that 8 of them will ask for time off. Determine whether the owner's estimate is likely. Okay, so let's set up a proportion just like we did before. Our total number of employees that we surveyed was 40, and of those 40, 8 of them said they'll ask for time off. This was the random sample. Let's compare that to the total number of employees that they actually have. Notice I'm comparing total to total. Total of my survey compared to total employees I actually have. I'm trying to find out what this equivalent ratio would be so that I know how many actual employees will ask off based on the results from this random survey. So a little bit of cross multiplication here. You take 8 times 1,200, a little bit of calculator work if you want, or you could do 8 times 12 if some of you might know a little mental math. That's 96 and add 2 zeros. So 9,600 equals 40 times x is 40x. And to isolate my variable, I'd have to undo multiplying by 40 by dividing by 40. So 9,600 divided by 40 would give me 240. So the owner estimated that about 250 employees will ask off, and based on our survey, we found that if this 8 to 40 ratio remains true, it's going to be about 240. So is the owner's estimate likely to be accurate? Yes, it is. 240 and 250 are really close together, so that's a good estimation by the owner. All right, that concludes the third lesson here on populations and samples. If you have any questions, please be sure to ask me, and I will see you next time.